Hello everyone. Today we're gonna discuss functions and relations in section 5.3. In the first part of this section, we're gonna learn the difference between a relation and a function. A set of ordered pairs written in this form, x and y, is called a relation in x and y. This ordered pair is also called a tuple, and it consists of two values. The first value is the x value, and the second value is the y value. The set of x values in the ordered pair is called the domain of the relation, and the set of all y values in the ordered pair is called the range of the relation. So we have two values. This is a relation, and the x values are the domain and the y values are called the range. The table shows a correspondence between the length of a woman's femur and her height. The femur is the large bone in the thigh attached to the knee and hip. You have two columns. This is the length and this is the height. The length of the bone in centimeters, these are the x values, and the height in inches are the y values. These can be written in the form of set of ordered pairs that defines the relation. So for x equal to 45.5, the y value is equal to 65.5, as you can see from this ordered pair. This is the first one. You open a, a bracket, and the brackets over here shows a set of ordered pair. We write all the ordered pair in this set. This is the second one, x equal to 48.2, and its y value is 68. And we write the other ordered pairs, and these ordered pairs defines the relation. Let's write the domain. We mentioned that the x values represent the domain of the relation. These are the x values. So again, we open a set, we open a bracket, and we list all the x values in the set from 45.5 to 50.4. And these are the values that represent the domain of the relation. As for the range of this relation are the set of y values. So we write all the y values in the set, and these numbers represent the range of this relation. Now, we've seen the definition of a relation. Let's define a function. Let's consider, for example, we have a relation between x and y. We say that y is a function of x if for each value of x in the domain, there exactly one value of y in the range. So in a function, you cannot have two same values of x. Let's take an example to understand it better. So we have this relation, three ordered pairs in the set. The first one is 2, 3, second one is 2, 4, and the third ordered pair is 3 and 5. As you can see here, we have two same values of x and different values of y. Since we have two same values of x in the first one, in the first order pair it is 2, and the second order pair is also 2, this is a same value, the same x. Therefore, we can say that this is not a function. However, for this set of ordered pair, this relation, we have different values of x. We have 1, 2, and 3. So we can say that this relation, this the set of these ordered pairs is a function. Although we have two same values of y, as you can see here, which is 3, that's not a problem. By definition, a function cannot have two same x values. We can visualize this by drawing or graphing a function, and we're gonna use a vertical line to test whether this curve is a function or not. Consider part A, and in this example we need to determine if the graph defines y as a function of x. As you can see here, we have a circle. To determine if this is a function or not, all you have to do is to draw a straight line. These are not exactly a straight line. The red ones are curves. You have to draw a straight line by using a ruler. I'm gonna try to erase this one. Okay, and draw a straight line. As you can see here, if we draw a straight line using a ruler, you're gonna see that this vertical line cuts the graph into at the same point. We drew a vertical line at x equal to 2. This is the value of x. This is the first unit. This is the second unit. This means that x is equal to 2. So at x equal to 2, we can see that this line cuts the curve into two same points. So at x equal to 2 at this point, and at also x equal to 2 at that point. So this means that this is not a function. As for part B, you can draw as many as vertical lines as you want. You're gonna realize that this vertical line cuts the graph at a single point and not twice. This means that we have a single value of x whenever we draw a vertical line at x. So we don't have for the same x 2 points, or in other words, for the same x two values of y. So yes, this is a function. For the third one, as you can see here, if you draw a function at a vertical line here at x equal to 0, why x is equal to 0? Because the vertical line has been drawn at unit 0 at here. So this line over here represent x equal to 0. This vertical line will pass through the function at this point, and on this graph at this point and at this point. So for a single value of x, we have two values of y, and this is, as you can see here, this is a function. However, look at the points over here. If you have something like that and something like that, this one means a full circle means that the point is included. An empty circle means that this point is excluded. Look at the graph over here. The 2 points here are included, which means that for x equal to 0, for this vertical lines, these are 2 points included in the graph, so this is not a function. However, if you have something like this, suppose that this one, this point over here, is an empty circle, which means that this point is excluded from the graph. We only have a single one over here, which is this one. This means that this point is included, a full circle. An excluded point and included point, this means that we have one single point at this vertical line. Since this one is included, and this one is excluded. So for a single value of x, we have a single value of y. In this case, yes, this is a function. We're gonna use this type of notation a lot in our lectures. Determine if the relation defines y as a function of x in this example number 4. Since for each value of x, there's a single value of y. For minus 2, y is equal to minus 2. For x equal to 6, y is equal to 6. And for x equal to pi, y is equal to pi. So there's no two values for x. This means that this is a function. Now, let's see whether these two functions represent a function or not. Y equal to 2x plus 6. Let's graph this function and see if this is a function or not, and use the vertical line method to check whether this is a function. Again, back to the graphing calculator, and the function is 2x plus 6. That's right, the function 2 times x plus 6. Let's graph this function. As you can see here, if you draw any vertical line on the graph, you will get a single value of x for a single value of y. As we move the point over here, as you can see, for each of x, look at the points at the values over here. For each value of x, you have a single value of y. This means that any vertical line we draw here, you will find a single value of x. I want you to go ahead and try to graph uh, this this function, and the result will be also a function. Use the graphing calculator and draw vertical lines and see whether this vertical line will result in cutting the graph in 2 points or 1 point. If it cuts it in a single point, this means that this is a function. If it cuts it in 2 points or more, this is not considered a function. In example 6, we will also determine if the relations defines a function, or we say that y as a function of x. Now, we mentioned before, to draw a function, you need to isolate y, which means we take y on the left side and take everything else, all the terms to the right side. This is given x is equal to 7 minus y. So we'll move minus y to the left side. This will be becomes positive y, and move x to the right side, we will get 7 minus x. So this is our relation that we need to investigate whether this one is a function or not. This is considered a function. Yes, this is a function because for any value of x, you will get one and only one value of y. So you can try it out. You can place any value of x over here, and you're gonna get only one single value of y. You can plot this one as well and see the graph if a vertical line cuts this in a 2 points or in a single point. You can try it out on a graphing calculator. Let's consider this given relation. Again, we need to isolate y. We take y to the left side. This will turn out to be positive, and move x to the right side. This will become negative x. Now, we have a square over here. We need to remove the square from the left side, and take the square root of the right side. And don't forget to add the plus or minus signs. Now, try to plug in any value of x. You will see you will get two values of y. Let's take this example. Let's replace x equal to 3 and calculate. You're gonna get 7 minus 3, which is equal to radical 4. But you have here plus or minus. You already have two values. You will get y. The result will be y equal to plus or minus 2. So you have two values. You have for x, for a single value of x, you have two values of y. One is plus 2 and the second is minus 2. So this one is not considered a function. As for this one, yes, this is a function because for any value of x you replace, you can try as many values as you want for x. You will get only one and only one value for y. We're done with part one. We have defined what is a relation, what is a function. In the second part, we're gonna learn the function notation. The function notation is written as such. We, we read this as f of x, which is f, the function is in, the y is in function of x. We can write this y equal f of x equal to 3x plus 1. Now, let's evaluate this function at a certain point. For example, in the first part, we will find f of minus 5, which means that x is equal to minus 5. So what you need to do is to replace the value of minus 5 in x here in the function. We replaced minus 5 in x. Minus 5 times 3 is minus 15, plus 1 is equal to minus 14. So for f of minus 5 is equal to minus 14, which means that we said that y is the f of x. So for x equal to minus 5, y is equal to minus 14. In part B, we will take x equal to 0. So you can take any value of x. So these are just an example for different values of x. In this case, we will take x equal to 0. Replace here x equal to 0. 3 times 0 is 0, and we have plus 1. 0 plus 1 is equal to 1. Try the other values. Replace other values like x equal to 5 and x equal to 10 in the function, calculate and check whether your calculations are correct or not. This is another example, a different function, g of x is equal to x squared minus 3x plus 1. Try different values of x, like x equal to minus 3, replace x equal to minus 3. If you have more than one term in the function, like in this case we have x to the power of 2 and we have minus 3x, you have to replace the value of x in all x in the equation, in this one and in this one, in all the terms, in the first term and in the second term. Replace x equal to minus 3, calculate, the result will be 28. In this case, recall that minus 3 to the power of 2 will be 9 because minus 3 times minus 3 is equal to 9. For this case, x is equal to radical 2. So replace the value of x equal to radical 2 in x squared and in x. The square of radical 2 will be 2. And minus 3 times radical 2 is minus 3 radical 2. So the final result, try it out, try the calculations, and you should obtain the result of g of x, g of radical 2 equal to 5 minus 3 radical 2. In example number 9, we have another function, h of x equal to radical 6 minus 2x. If we place 3 in the function, taking x equal to 3, replace it in x over here, you will have 6 minus 2 times 3. 2 times 3 is 6. 6 minus 6 is 0. Radical 0 is 0. For h of a 4, this is very important, and be careful and please note this calculation. So for x equal to 4, replace it in x. For x equal to 4, 2 times 4 is 8. 6 minus 8 is minus 2. As you can see, we cannot evaluate square root of minus 2. This is undefined in mathematics. The square root of a negative number cannot be calculated, so we will write undefined.